Hi, Craig from Total Miner here. We have added the Lua programming language to Total Miner. Lua is a full proper programming language, a lightweight programming language. So it has variables, functions, all that sort of stuff. Many games use Lua as a scripting language for the game. So we hope Lua will be, well, it will certainly be more powerful than the the built-in Total Miner scripting language. So we hope it'll allow people to be a bit more creative. So I'm going to just do some basic tutorials just to cover the basic fundamentals of Lua, and hopefully that might help some people get started. I will create a just a flat creative world. So Lua is an extensible lightweight programming language written in C. It's used in game programming. It's very simple. I don't need to go over this stuff. So in Lua you just type in identifiers, which are names for variables or functions or other user-defined items. Identifiers must start with a letter, A to Z, or an underscore. They can have digits, numbers in them, but they can't start with the number. Here's some examples there. These are the keywords of the language, not very many, which is good, not much to learn. And that's creating a variable called age. White space, so everything is just separated by white space. So for example, you need a space in between local and age so that the language knows that you're using the keyword local and the variable or the identifier age. So we'll start with variables. I'm not going to go into the differences between local and variable and global. We'll just use local for now. But essentially a variable is just a name or an identifier for some value, some space in memory. So if you create a variable called I, the programmer is creating some space in memory which is referenced by using I, and you can store values in that memory. So here we create a variable called D and F. Each one of those two variables is allocated some space, and we assign the value 5 to the space in F and D, and 10 to the space in F. So when we use D in the program, we're referring to a memory location, and currently that memory location will hold the value 5, and for F it'll hold the value 10. So this is showing how you can create two variables on the same line and assign them values. You don't have to do it on separate lines. It's just a bit of a shortcut, shorthand. So let's create our first Lua program, which will be a traditional hello world. New script. So if you come in here and you type in something, you can see this is the old. This is not the it's not the old, but it's the built-in Total Miner script language here. So we don't want to use that. We want to use Lua. So to use Lua, what we need to do is we just append _Lua to the end of the script name, and that lets the game know that this is actually going to be a Lua script and not total minor script. So here we can say print hello world, run that script. There it is at the top left. We can also use notify, which is kind of a wrap of print. But it's so that we can use notify, which is like, excuse me, just using the same syntax as the total minor script notify command. It basically does the same thing. It's basically the same as print. Okay, so we can create some variables. Let's say cars equals 10, trucks equals 5. And we can do this. We can say vehicles, cars plus trucks. So that's printing a string there, and then it's printing a value, which is the result of cars plus trucks. 15. We can also do this. Okay. We can put these on the same line. Should be same result. So the program is creating some space in memory for cars, allocating some space. It's allocating some space for trucks. It's assigning the value of 10 into the memory for cars. It's assigning the value of 5 into memory of trucks. It's creating some allocating some space for a variable called vehicles, and it is running that equation there, cars plus trucks. So it takes 5, and it takes 10 from cars, 5 from trucks, adds them, and puts the result into memory identified by vehicles, and it just prints that whole string there. Then it prints the value from those 3 variables. That's the types of variables. You can have a bool variable, numbers, strings, functions. Arithmetic operators: addition, subtraction, multiplication, divide, modulus, exponent, unary. Comparative operators: is equal to, is not equal to, greater than, less than, greater than, equal to, less than, equal to. Logical operators: miscellaneous operators. Here's a concatenation, string concatenation operator. So for example, if you have first name then you can do do that. You can concatenate several strings, so we can actually put a space in there. And there are some precedents. If you have an expression with several operators, there is some precedence rules, and you can use brackets to control that if you need to. Okay, so next we have control flow. So we have some while loops here. This is just an infinite loop. This will loop forever with each loop that has a 100 millisecond delay. So a standard while loop starts with a condition. It evaluates that condition, and if the condition is true, it will come into the loop body here where there's statements, execute those statements, and then at the end command keyword it will come back to the top, reevaluate that condition. If the condition is true, it will come back into the loop again. Otherwise, if the condition is false, it will exit out of the loop and continue after the end statement. So here is an example. Oops. So we set a equals 10. At the start of the loop, we run the condition, which is comparing if a is less than 20. So a is 10, so it is less than 20, so it will come into the loop. It will print a. It will add 1 to a, so now a will equal 11. It will finish the loop and come back to the top, reevaluate the expression, the condition. A is now 11, so it's less than 20, so it will come back in, and it will keep doing that. It'll be 12, 13, 14, until it gets to the value of 20. Then it will say, is a less than 20? And it is not. It is equal to 20, so it will exit the loop down here. And we can put a at the end. Okay. We can of course run that backwards, so we can set a to 20, and we can say while a is greater than 10, and we can subtract 1 from a. So it starts at 20, comes down to 11, exits on 10. A for loop. It's also a loop, but it has a slightly different structure. for controlling the loop. It uses what's called a loop variable or a loop counter, and it has a syntax where you initialize the counter here, you set the bounds or the minimum and maximum value that the counter can have, and then you set here what value is added to the counter each iteration of the loop. So here we have a basic example. So I starts at 10, sorry. And while I is greater than 1, greater than equal to 1, while the minimum value of I is 1, so while I is greater than or equal to 1, it will do the loop, print the I, and then at the end of the loop, when it hits the end statement, it will come up and it will add this value here to I, so I will now become 9, etc. It will loop. When I is eventually reaches 0, it will cancel out of the loop. And we can of course do that forwards, so we start I at 1 while I is less than 10. We add 1 to I. Actually, let's just say let's add 2 to I. So you can see there 1, 3, 5, 7, 9. The next value was 11, so that's greater than 10, so it cancelled, didn't print it. That's a very common loop structure. That's one of the most common ones. The while and the loop, for loop are the two most common ones. Here we have a slightly different structure. This one is useful when you want to do the statements regardless, always at least once, and then at the end you want to check the condition if you want to then go and do it again. So A equals 10. We will always do this at least once. We do it. We add 1 to A, and then we check the condition. Is A greater than 15? If it's not greater than 15, we go back and repeat the loop. So this condition here, we repeat the loop until this condition is false. Once this condition is false, we repeat this loop until this condition is true. Once this condition is true, it falls out of the loop. So if you were to subtract 1 here, you'll find that that loop will never end, because it will go, its first value was 10, it'll print A, the next value will be 9, 8, and then it will go into the negatives, and it will never ever be greater than 15, so we'll just see, we'll just go forever. Yeah, there we go. It's just there's a delay in the... So I have to cancel that script there. And the last one is just nested loops. It's just loops inside loops. I don't think we need to really go into that. There's a break statement, so you can break out of a loop under some separate condition that's different to the main loop condition. So for example, you're doing some loop and there might be some exceptional case where you want to break out of the loop early, and you can use the break command to do that. Let's actually do some practical loops. So if we want to excuse me, let's say we want to set a line of blocks. let's say we want to, we can actually use a for loop. While x equals, let's actually say 0. It's not even, it's 0, 1, 0. We'll set to 0 while it's less than 20. We'll add 1 to it. It does use the do command, does it? Yeah, it does. And we'll set a block here. We'll set, say, wood plank. So that's going to set that wood plank from position 0, 201, 0. And then x is going to be incremented. So the next one will be 1, 201, 0, then 2, etc. until we get to 20. There it is there. So that's 20. That's 0, right? So it actually went from there and it put them all the way down there. Now let's say if we make that 2, it's incrementing by 2 each time. Right? And let's say we want to animate that. If we want to animate it, we need to put a weight in here and a commit. A commit causes the game to rebuild the block mesh, so you can actually see the blocks. I probably need to clear that out too, don't I? Just clear out this region. X plus 20, Y, Z. 0 is just air. So this is going to animate. This here, we can make it a variable, so we can make it faster or slower. It's faster, 100 milliseconds, so 10 times a second, 10 blocks a second. And if we want to, let's say we want to we can do this is an example of a loop within a loop, a nested loop. So it's going to do too high. Okay. And let's say we want to, we can make these also, we can make these variables as well. So let's say we want to change the size of the line. We can make say, make it 15. We can keep that like that for now. And we can make that a bit faster. This is only going to do 15 now. Did I add it? Did I not get rid of that last end there? Okay, and finally let's wrap it all the way around us into a square. So to do that, we can just use 4 loops. And this loop is going to be Z. It stays the same. And this loop now is going to, see here we don't even need to set X, I think. We can just, and that's going to go back to 0, and it's going to be -1. Yeah, we probably do need to set X. Probably just set it to size. So this is effectively going backwards. And same with Z. I'm not quite sure what it's doing with these, if that X is different to this. So what I might do is, I'm going to change it to a while. So I'm going to say while X is less than size, and here I'm going to say while, I think 4 is probably not appropriate, 4 loop's probably not the right one for this. Because we want to retain the values of the X and the Z outside these loops. So I think with the for loop, I think that X is probably local just to the for loop. Whereas with the while, there's no loop counter, so we'll be using the one up here. Yeah, so that's better, right? And of course we can make the block itself a variable. Everything can be variables, and the more variables you use, the easier it becomes to change stuff later. For example, every loop we can make block ID, a random block, we can also put this whole thing into a loop. Infinite loop, so we'll just keep on doing it. That's nested loops within a nested loop. Oh, sorry, nested loops within one main loop. Interesting, it doesn't clear the top one. Not really asked to do that much else to do here. We can just show that if we change that to 50, just makes a much bigger loop. Okay, what else we got? If statements. So that's a conditional control, conditional flow. By the way, you can edit more than one script at a time here. If you go and click New, you can now swap between the two using that drop down there. Hasn't updated the name there. Never mind. So this is setting a to 10. If a is less than 20, which it is, then it runs that, and then it runs that. And that script is still running, is it? Okay, finish now. So for example, we can do something like and we can say equals grass. We can say if block. By the way, the brackets are optional, I believe. Block ID is equal to grass. Then we're going to set equal to dirt. Else equals block.grass. And then we'll just set the block there. Have a wait, commit, wait. So we set the block to grass. If the block equals grass, we then set it to dirt, otherwise we set it back to grass. And we draw the block, place the block, excuse me, and just loop over and over. So it should be alternating between dirt and grass. I missed something there. Maybe it does need to be brackets. There's a do. Okay. Missed the do there. So maybe you can see it's alternating between grass and dirt. You can also we actually did do an else, didn't we? So there's the else. The else is optional, we don't need that. You can do that. And there's a third one, which is else if here. And you can have as many else ifs as you want. So we can say else if block dot dirt, then block equals block dot sand, else if block sand, then say clay, limestone, else so it's going to loop between grass, dirt, sand, limestone and serpentine. No, we don't want that there. We want that to set that back. That should be setting it back to grass. Grass, dirt, sand, limestone. So I hope that's fairly straightforward there. And next we have functions. I won't go into functions today. I'll do that for the next tutorial. What I will show you though is just we have some documentation here on this URL. With Lua scripting we have a brief explanation of some of the data types. Here's the blocks that I was using. These ones here. And all of the functions that the game supports for Lua. So there's zones, blocks, etc. Right? All the get ones. There's the get random there. Okay, I think that'll do for this tutorial. Just one more thing to add for the editor. If you're not sure what function, you just start typing. Let's say just start typing and it will bring up a list here of everything that matches what you've typed. So that will help you to find what you need. Right, if you want to, let's get history there. I think you might have to start the line again to get it again. Oh no, you just press Control. You used to be able to press Control J. Okay. Maybe Control Space looks like. So that's how you find what you want. And you can click help there to bring up that. You won't get this problem, don't worry. Bring up this website here. Insert commands. That's actually only used by the built-in team script, so don't use that. Copy paste is for copy and pasting text within here, and you can use paste windows if you copy some text from outside Windows, and from Windows. You click that and it pastes it in here. You can use find and replace. So if I want to find inventory, whatever I type, you see it highlights it here. NPC. You can go to line number. If I want to go to, if I've got a big script, I want to go to line, some line number off the screen, just type it in there. And the rest of the stuff is like the old editor. Okay, that'll do. So for the next tutorial, we'll have a look at some functions. Cheers.